9 raised to the power x plus 12 raised to the power x equals to 16 raised to the power x. We have to find the value of x. How to solve this? Now if you convert this into old method of dividing both the sides by a common denominator. So if we divide both the sides by 9 raised to the power x, then we are not changing the equation. Now this means we can write 9 to the power x upon 9 to the power x plus 12 to the power x upon 9 to the power x equals to 16 to the power x upon 9 to the power x. This and this gets cancelled. Now this is 1 plus 12 to the power x, 9 to the power x, we can write 12 upon 9 whole to the power x equals to 16 upon 9 whole to the power x, because there is a rule of identity. If a to the power m upon b to the power m, then we can write a upon b whole to the power m. So using this identity we have written here. Now 1 plus, let's reduce this fraction. 3 times 4 is 12 and 3 times 3 is 9. So this is 4 upon 3 whole to the power x equals to 16. We can write 4 to the power 2 and 9 as 3 to the power 2 whole to the power x, or 1 plus 4 upon 3 whole to the power x equals to 4 upon 3 whole to the power x, then whole to the power 2. Now let us consider 4 upon 3 whole to the power x equals to m. Then we have 1 plus m equals to m square, or we can write m square minus m minus 1 equals to 0. This is a quadratic equation now. Let's find the roots for this equation. So minus b plus minus b square minus 4ac under square root upon 2a, where b here is the coefficient of m. So minus 1 plus minus minus 1 whole square minus 4 times a is the coefficient of m square, so 1 times c is minus 1 upon 2, or 1 plus minus 1 minus minus plus 4 upon 2 equals to 1 plus minus square root of 5 upon 2. Now m equals to 1 plus square root of 5 upon 2, and second value for m is 1 minus square root of 5 upon 2. Recall that m equals to 4 upon 3 whole to the power x. But when x is a real number, it is an exponential function which always be greater than 0. Therefore, we cannot take this negative value. Therefore, 4 upon 3 whole to the power x equals to 1 plus square root of 5 upon 2. Now let's take log to both the sides, or x log 4 upon 3 equals to log 1 plus 5 under square root upon 2, or x equals to log 1 plus square root of 5 upon 2 upon log 4 upon 3, and which approximately comes to 1.673. How did you solve it? Let me know in the comment section. Thanks for watching.